Hello everyone, today we are talking about section 1.5, which are properties, or they're sometimes called laws of exponents. Just a quick note here, you have learned all of these before. This was actually an entire unit in Algebra 1, so you can think of how much we normally have in a unit crammed into one section. There is a lot in here, but the nice thing is you've seen all of this before. So this is more or less just a review, make sure we're all on the same page before we have to use this stuff throughout the year. So, talking about exponents, we're going to be simplifying expressions that involve exponents. We need to kind of talk about what exponents are. So first of all, if I have a variable raised to an exponent, that exponent tells me how many times that variable, or if it's a number, shows up. It's multiplied that many times together. This entire thing here, where I have a thing raised to a power, or raised to an exponent, is what we call a power. And you can hear I even struggle with my words there. We sometimes say this exponent is a power as well, but a power as a thing is just this entire thing. But we say this could be a to the nth power, meaning it's the exponent. A couple other words here that we do need to talk about are the base. That's the bigger number, the number that's written out multiple times. So this is the number, the numbers or variables that are raised to the exponent. You could also say this is the pieces that are multiplied together. Next we have the exponent itself. Those exponents are those numbers that are raised up as the smaller pieces. This is the number of times the base is multiplied by itself. That's how many times am I actually multiplying that base together. Real quick here, let's talk about exponents and how they're related to parentheses. Let me give you a few examples here. They look very similar, but they all mean slightly different things. So I have negative 2x squared, then I have negative with a 2x in parentheses squared, and then I have the entire negative 2x raised to the second power in parentheses. Okay. The short answer to the difference between these is that an exponent only applies to the piece directly in front of it. So in this first one here, if I wanted to expand this out or write out all of the multiplication, the negative 2 shows up one time, but the x's show up twice. In the middle one, the negative only shows up once, but a 2x shows up 2 times. In the final one is where I actually get a negative 2x times a negative 2x. Now, because of the way the numbers work out and everything else, all three of those mean completely different things. So it's very important to understand what parentheses are in terms of those exponents and what's actually part of that base. Basically, those parentheses are indicating what your base is. That's the thing that's raised to the power. Anything that's outside the parentheses, or if there aren't any, those are not raised to that power. Just the one thing directly in front of the exponent is. So with that being said, let's talk about example 1 here. Example 1 just asks us to write out each expression in expanded form. Expanded form is basically what I did at the bottom here, writing out all of the multiplication. So if I have a here, I have 5z raised to the second power. Now again, I have parentheses, so that squared applies to everything on the inside of the parentheses, which means I have this 5z, and I have that 5z being multiplied 2 times. So that is my expanded form. Part B, I have 3b raised to the 4th. Now here I don't have the parentheses, so the 3 is not raised to that power. So the 3 will only show up one time, but the b is raised to the power. That shows up the 4 times. So I have 1 3 followed by 4 b's. Next we have negative s to the 3rd. Negatives can sometimes be tricky. A lot of times, and this is kind of some of our teachers' fault too, and I'm guilty of this as well, we say treat that negative as part of the s. It actually comes with it. This is one of those cases where that's actually incorrect. We got to make sure that we know that that negative is not part of this s. The s is raised to the 3rd power, but the negative is not. So that negative sits on the outside, so we just have one of them, and I don't have 3 s's that come with it. Hopefully that makes sense. Moving to the last one here, 3 doesn't have an exponent, so it's just one of those. H has a power of 3, so I have 3 of those. And now I have this group that's in parentheses, k plus 3. Now because it's a plus, I'm just going to keep it together in parentheses, k plus 3. And I have 2 of those because I have a second power as my exponent. So kind of just splitting those up based on how many exponents there are, that's how many times that one piece shows up in our expanded form. All right, let's go ahead and get into some of these properties. So in total, there are 6 properties that we're going to deal with. Some of them are bigger than others, some are easier than others. We're just going to kind of start to work through them, and then we'll get into some examples and how we combine some of these together. So first one is the 0 exponent property. Hopefully you remember this one. This is probably the easiest one. A quantity raised to the 0 power is 1. And that's it. So any number that I raise to the 0 power is always going to be 1. Doesn't matter if it's 5 to the 0 power, that's 1. 243 to the 0 power is 1. There's lots of different options of what can be raised to the power, but if it's raised to the power of 0, it's going to be 1. From the easiest one, we probably move to the hardest one, which are negative exponents. Negative exponents are tricky mostly because they don't work like normal exponents. What a negative exponent actually does, it says that we're going to move where things are at, and then we'll work with our other properties. So a negative is really just telling us we're moving things. So a base raised to a negative exponent, and I'm abbreviating there, negative exponent, I'm going to be in exp, is equal, so it's the same, to its reciprocal raised to the positive exponent. Okay, so basically I'm taking a negative exponent, I flip a fraction, and that makes our exponent positive, and then I can go from there using my other properties. So for example, if I have a divided by b is being raised to the negative n. That negative tells me I need to flip my fraction, so b is on top and a is on bottom. But because I did that part of it, my exponent is now a positive. The negative just tells me to switch, then I keep the exponent the same, just dropping the negative because I dealt with that piece. One with numbers might look like this. 3 over 2 to the power of negative 4 is equal to 2 over 3 to the 4th power. And then I could continue on and kind of figure out what that is. Trickier one might be something like 5 to the negative 3rd power. Because I don't have a fraction to start, I'm going to make this over 1, which means when I flip it, it's going to be 1 over 5, all raised to the positive 3rd power. And again, you could then kind of continue from there. And we'll talk about how to do those here with our other properties. Okay, but biggest thing is we're flipping the fraction. If we don't have a fraction, we'll make it over 1 and then flip it. The other thing you can think of is if we actually have a fraction existing already, you can think of anything that's in the top moves to the bottom and the bottom moves to the top. Okay, if you think of this like a house, anything on the 2nd floor moves to the 1st floor, anything from the 1st floor moves to the 2nd floor. Bottom to top, top to bottom. Okay. Talking about the product property. If that name product does give away part of what this is, product refers to multiplication. So this is going to be to multiply powers with the same base. So it is important that if it does not have the same base, this doesn't work. So it has to have the same base. Then you simply add the exponents. Okay, so if I have the same base, I just add my exponents. So for example, I have x to the power of m times x to the power of n. My bases match because they're both x's, and I have these exponents that I would then add together to give me my new exponent on just that one base instead of 2 separate bases. So with numbers, might be 2 to the 3rd times 2 to the 4th. Well, 2 to the 3rd and 2 to the 4th have the same base, so I just add the 3 and the 4, and this is now 2 to the 7th. Okay, this is one that I can actually kind of show you what this is. If you want to, you can think of 2 to the 3rd as 2 times 2 times 2. 2 to the 4th is 2 times 2 times 2 times 2. And really I'm multiplying in the middle, which combines those together. Now I have a string of 7 2's, which is simply 2 to the 7th. So that one's a little bit easier to see, kind of the property that goes with that. All right. Moving on to the next page. Sorry, I moved that kind of fast. If you need to go back and pause the video, you can. But I'm going to keep going here. So, quotient. Quotient refers to division. So we're going to say to divide powers. With the same base. We simply are going to subtract the exponents. And some of you might remember that, or you might guess that just from the fact that multiplication is the opposite of division. So we do the opposite of addition, which is then subtraction. So we subtract those. So this is going to be x to the power of m divided by x to the power of n. If I divide those, that means I'm really just going to take the 1x and do it as m minus n. And the order of that is important. This is always the top number minus the bottom number. Okay, you got to make sure your order is correct there when we're doing our subtraction. With addition, it can switch. So we're not too worried about that. Let's give you an example here. 4 to the 7th power divided by 4 to the 3rd doesn't equal 4 to the 4th. Okay, because 7 minus 3 is 4. That one, again, I can show you a little bit. I'm not going to go all the way through this. We have 4 times 4 times 4 times 4. I guess I'm going to go all the way through it. 7 times. Should be 7 fours there. And I'm dividing it by 4 times 4 times 4. 4 to the 3rd. Well, these 4s cancel if they make a pair. And if they cancel like that, then I'm left with 4 on top, which is simply 4 to the 4th. You can multiply it out and get your number for an answer. Okay. It is important here. I'll just mention at this point. We'll get to it more in example 2. If it's all numbers, I do need to try to get to a single number answer. If there's variables involved, I might not be able to get to that, but I need to get as far as I possibly can. Next one, power to a power. So this is if we have something with an exponent that's raised to another exponent. So to raise one power to another, meaning I have 2 exponents, one raised to the next, then we multiply our powers. Sorry, exponents. Just the exponents. Okay, so that's going to look like x to the power of m gets raised to a second exponent, so we'll say n. Then in order to simplify that, I'm going to say that's x to the power of m times n. So I multiply those 2 exponents together. With numbers, that might be 3 to the power of 4 raised to the second power is the same thing as 3 to the power of 8. And again, if it's just numbers, you could continue on. Power of a product and power of a quotient properties. This is actually 2 of them combined into 1. Really, it means I have a product and I have a quotient already established, and then I'm doing the power of that. That means that I have exponents typically outside parentheses. So exponents outside parentheses. Those apply to each part inside. Okay, and it is important again to remember that this is only if we're multiplying or we divide inside those parentheses. If it's not, then we have to talk about expanding it and doing some foiling and that sort of stuff. We won't deal with that yet, but just know that we can't quite do that here. Okay. As far as showing you this, if I have something like x times y raised to the power of n, that's the same thing as saying that that exponent applies to x and to y, and I keep the multiplication in between. Same thing if it's already in a division, x divided by y to the power of n, x gets the power as well as y, and I keep the fraction that they're already in. As far as numbers, it's a little bit weird with numbers because order of operations tells us we would actually multiply these together, but it is the same thing as taking 3 squared and 4 squared and multiplying those. So it's the same, it does work out, but based on order of operations, we probably wouldn't use this property for just numbers. That's why I'm kind of just writing these down here. I'm not too concerned about you knowing those ones. Again, you can go further all the way to the number answer. We'll do that here in example 2. All right, I didn't switch colors on the last one, but it works. All right, example 2, we need to simplify our expression. So we are simplifying. Our goal is to get down to a single number, and if we have variables, just one of each of those variables with a positive exponent. So So I need positive exponents on variables, just one of them, and just a single number. So single number, single variable, positive exponent. That's how we know things are simplified. So let's go ahead and start with the first one here. I don't have any variables, so all I have to do is get this down to a single number. But I have this exponent I have to deal with. So we'll start with the negative. A negative means I need to flip this fraction. Well, I don't have a fraction, so I'm going to make it 1 and put it over 1. Then from there, I'm going to go ahead and flip that. So when I flip it, the 1 moves to the top, the 3 goes to the bottom, and that's all raised to the second power. Excuse me. And then when I square this, I know that that square applies to both pieces. So this is going to be 1 squared divided by 3 squared. 1 squared is simply 1. 3 squared is 9. So my answer here is 1 divided by 9. Just a single number for an answer. I didn't have variables, so I'm good to go. Part B, I'm going to actually start with my variables here. I have a z to the 7th and a z squared. These are being multiplied because I don't have any adding or subtracting symbols in between, so I am multiplying here. And I need to, if I'm multiplying, add those exponents together. So I'm going to add the 7 and the 2, which gives me z to the 9th. Then I have this regular 3 and negative 4. Those are regular numbers. They're not exponents, which means they follow the operation that I have. They don't follow these extra rules that we were talking about today. So the 3 and the negative 4 do get multiplied. 3 times negative 4 gives me a negative 12. Okay? And I know that might be a little bit confusing. We just talked about all these rules, but now we're not using them. But remember, those rules apply to exponents. 3 and negative 4 are not exponents, so I can't apply those rules. That's one of the most common mistakes that I would see is somebody add those together instead of multiply because they're trying to use the same exponent rules. Next one here, we'll switch colors for this one. 52 to the 0 power. Well, anything to the 0 power is 1. So write a 1, circle it, put this box around it, highlight it, whatever you're going to do, you're done. That's it. So that one's easy. Let's go on to the next one. We'll take, and this one I have this exponent that applies to this group of parentheses. So I'm going to take that 3 and I'm going to apply it to both the 5 and the x to the 6th. Well, if I do that, I end up with a 5 to the 3rd, and that's going to get multiplied by x to the 6th. I'm going to throw it in parentheses and raise it to the 3rd power. The parentheses are there just to kind of keep that power separate from the 6. I can start to simplify that. 5 to the 3rd is 125. If you don't know that, you can grab a calculator and work through that. Then I have the power raised to another power. In our exponent rules, if we go back up here, power to a power, we multiply. So I'm going to multiply the 6 and the 3, which means this is an x to the 18th power. So 125x to the 18th, that is my answer. Last two here, E, I have 2/3 to the power of negative 3. Negative 3 is going to first, flip my fraction here, which gives me 3 over 2 raised to the positive 3rd power. Then similar to A here, I know that that power applies to both top and bottom. So it's going to be 3 to the 3rd and 2 to the 3rd. 3 to the 3rd is 27. 2 to the 3rd is 8. Double check those again in your calculator if you want, and that is my answer. The one thing I should double check here is that I cannot reduce this. I will tell you 27 and 8 do not reduce. That is your reduced fraction. The way I do know that is if you cannot reduce the fraction before you apply the power, you will not be able to reduce the fraction after. So if you want to look at 3 over 2, that's reduced, so we're good. All right, last one here. We'll stick with orange. I'm going to actually start on the outside of this one. I have this 3 on the outside, and I'm going to bring that into everything. So when I do that, a y gets a 3rd power. The z to the 3rd already has a power, so I'm going to put in parentheses, raise it to the 3rd power. And on the bottom, z to the 5th, again, already has one, so it goes in parentheses to the 3rd power. My power to a power is there. With my parentheses get multiplied. So this is going to be a y to the 3rd and a z raised to the 9th over, the 9 is from 3 times 3. And then z here, I'm going to have 5 times 3, which is 15. Okay, now, that might look simplified because all of my powers are positive, but if I look closely, I have 2 groups of z's here. I need to combine those together. So if I ignore the y to the 3rd, that's just sitting on top. I have this division with my z's. If I cover this up, you can see I have this fraction in the division. With division, I need to subtract these, and we always do top minus bottom. When I do that, 9 minus 15 gives me z to the negative 6. So negative 6 is now my exponent. but that's negative, so I can't stop there. I need to flip just that part. Now, because it's not a fraction, I'm going to put it over 1, which means when I flip it, this is going to be y to the third times 1 over z to the sixth, which can look simplified, but I can combine those together. If I'm multiplying something by a fraction, I can just bring it into the top. So y to the third goes up top, z to the sixth goes to the bottom. There is my final answer. And again, all positive exponents and only one of each variable. Okay, you are going to run into some in your homework that are a bit more complicated than this, combines more of them together. Do your best to try and work through those. If you get stuck, let me know. Otherwise, we will see you next time.